Previous class we have discussed Z transform definition and standard results on Z transform. So in today's class, examples on standard results on Z transform. So first one, Z transform of A raised to n cos n theta is equal to Z minus A cos theta divided by Z square minus 2AZ cos theta plus A square. Second one, Z transform of A raised to n sin n theta is equal to AZ sin theta by Z square minus 2AZ plus A square. Right. Here we know what is, we have proved this. Z transform of cos n theta is equal to Z minus cos theta divided by Z square minus 2Z cos theta plus 1. If suppose in exam, if they have asked Z transform of A raised to n cos n theta is equal to Z minus A cos theta divided by Z square minus 2AZ cos theta plus A square. So first you need to prove what is Z transform of cos n theta. Later you apply damping rule. So here I'll write, we know that Z transform of cos n theta is equal to Z minus A, Z minus cos theta divided by Z square minus 2Z cos theta plus 1. Now in place of Z, you substitute A inverse Z or Z by A. So we'll get here as A inverse Z minus cos theta divided by A inverse Z raised to 2 minus 2 A inverse Z cos theta plus 1, or else you replace Z, A inverse Z as a Z by A. Now take LCM and simplify. So here LCM is A in the numerator. So you'll get Z minus A cos theta divided by A and multiply this with Z by A. So you'll get numerator as Z minus A cos theta divided by A square, and denominator A square is LCM, and we'll get this as Z square AZ cos theta plus A square divided by A square, and take reciprocal. A square divided by Z square minus 2AZ cos theta plus A square. So A square get cancels. So the transform of A raised to n cos n theta is equal to Z minus A cos theta divided by Z square minus 2AZ cos theta plus A square. Now second one, Z transform of sin n theta is equal to Z sin theta divided by Z square minus 2Z cos theta plus 1. So we know what is Z transform of sin n theta. So I have written here directly, but in exam first you need to prove this, what is the transform of sin n theta, then later you apply damping rule. So we want the transform of A raised to n sin n theta. So in place of Z, substitute Z by A. So you'll get here as Z by A or A inverse Z. So Z by A sin theta divided by Z square A square plus 2 Z by A cos theta plus 1. Now take LCM and simplify in the denominator. So numerator no problem, sin theta. Denominator A square is LCM. Denominator A square is what here? LCM. Take LCM as A square. So left with what here? Z square plus 2AZ cos theta plus A square divided by A square. So take reciprocal. So A square divided by Z square plus 2AZ cos theta plus A square. So A get cancels with this A square. This A and this Z is AZ. This sin theta is as it is. Denominator Z square plus 2AZ cos theta plus A square. Thus Z transform of Z transform of A raised to n sin n theta is equal to AZ sin theta divided by Z square plus 2AZ cos theta plus, so this is the right answer. Now next example, obtain Z transform of cos hyperbolic n theta and Z transform of sin hyperbolic n theta. Right. So here we have a property. We can convert this hyperbolic function into exponential. So take advantage of this. So cos hyperbolic n theta is equal to 1 by 2 e raised to n theta plus e raised to minus n theta. So this is equal to 1 by 2 e raised to theta raised to n plus e raised to minus theta raised to n. So I'll take e raised to theta as a p, e raised to minus theta as a q. So we'll get here as cos hyperbolic n theta is equal to 1 by 2 p raised to n plus q raised to n. So where p is e raised to theta and q is e raised to minus theta. Now z transform of cos hyperbolic n theta is equal to z transform of p raised to n plus q raised to n. So apply linearity property. Just apply this z transform for both the terms separately. So we'll get here as 1 upon 2 z transform of p raised to n plus z transform of q raised to n. So we know that this is a standard result. Z transform of e raised to n is z divided by z by a. In place of a we have p. So 1 by 2 z divided by z minus p plus z divided by z minus q, because z transform of q raised to n is z divided by z minus q. So 1 by 2 z divided by z minus e raised to theta plus z divided by z minus e raised to minus theta. Now take LCM. Here z is common. Take it outside. So left with what here? Z by 2. And take LCM. Z minus e raised to theta is there. Multiply z minus e raised to minus theta. And this plus sign is as it is. Z minus e raised to minus theta is there. So multiply raised to theta, right? And denominator you multiply these two, right? So multiplying these two, we'll get it here as z square minus z e raised to theta plus e raised to minus theta plus 1. So here z plus z will be 2z minus e raised to theta plus e raised to minus theta whole divided by z square minus z e raised to theta plus e raised to minus theta plus 1. Right, z by 2 is as it is, but we have e raised to theta plus e raised to minus theta is equal to 2 cos hyperbolic theta. So e raised to theta plus e raised to minus theta will be 2 cos hyperbolic theta. E raised to theta plus e raised to minus theta divided by 2 is cos hyperbolic theta, and take this 2 to this side. E raised to theta plus e raised to minus theta is 2 cos hyperbolic theta. So substitute here. We'll get it here as z by 2 2 by z z by 2 2z minus 2 cos hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1. Here numerator 2 is common, take it outside and cancel this. So we'll get here as z transform of cos hyperbolic n theta is equal to z minus cos hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1. Right. Similarly, we know that sine hyperbolic n theta is equal to e raised to n theta minus e raised to minus n theta divided by 2. So again, sine hyperbolic n theta is equal to e raised to theta raised to n minus e raised to minus theta raised to n divided by 2. So this is equal to 1 by 2 p raised to n plus q raised to n, where p is e raised to theta, q is e raised to minus theta. So here in place of plus it is supposed to be minus. Please do correction, right? So z transform of sine hyperbolic n theta is equal to 1 by 2 z transform of p raised to n plus z transform of q raised to n. So 1 by 2 z transform of p raised to n is z divided by z minus p minus z transform of q raised to n is z divided by z minus q, and here replace p and q. P is e raised to theta, q is e raised to minus theta, and take LCM. So e raised to minus z minus e raised to theta is there. Multiply z minus e raised to minus theta. Here z minus e raised to minus theta is there. Multiply z minus e raised to theta, and denominator we have these two, so multiply these two. So next step will be z by 2 common for both the terms. So z minus e raised to minus theta minus z plus e raised to theta divided by z square minus 2 theta plus z square minus e raised to theta plus e raised to minus theta into z plus 1. So minus z plus z get cancels. So e raised to theta minus e raised to minus theta divided by z square minus e raised to theta plus e raised to minus theta z plus 1. But e raised to theta minus e raised to minus is equal to 2 sine hyperbolic theta, and the e raised to theta plus e raised to minus theta. So this is equal to 2 cos hyperbolic theta. So substitute. So the transform of sine hyperbolic n theta, this is equal to z by 2 into 2 sine hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1. 2 get cancels. Z sine hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1. So the transform of sine hyperbolic n theta is z sine hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1. Now next one. So obtain z transform of e raised to n cos hyperbolic n theta and z transform of e raised to n sine hyperbolic n theta. So here we know what is z transform of cos hyperbolic n theta. Directly we'll write, but in exam first you need to show what is z transform of cos hyperbolic n theta and sine hyperbolic n theta. Then you apply damping rule to these two. Now we know that z transform of cos hyperbolic n theta is equal to z minus cos hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1. Now the transform of a raised to n cos hyperbolic n theta is apply damping rule. So replace z as a inverse z or z by a. So we'll get here as z by a minus cos hyperbolic theta divided by z by a raised to 2 minus 2 z by a cos hyperbolic theta plus 1. So here take LCM and simplify. We'll get here as z minus a cos hyperbolic theta divided by a square, and taking reciprocal a square divided by z square minus 2az cos theta plus a square, right? So a square get cancels. So the transform of a raised to n cos hyperbolic n theta is equal to z minus a cos hyperbolic theta divided by z square minus 2az cos hyperbolic theta plus a square. So this is required answer. Now for second one, we know that the transform of sine hyperbolic n theta is equal to z sine hyperbolic theta divided by z square minus 2z cos hyperbolic theta. But if they asked the transform of a raised to n sine hyperbolic n theta, so first you need to show what is the transform of sine hyperbolic n theta. Later you apply damping rule. Now z is replaced by z by a or a inverse z. So we'll get it here as z by a sine hyperbolic theta divided by z by a raised to 2 minus 2 z by a cos hyperbolic theta plus 1. Now take LCM and simplify. Z sine hyperbolic theta divided by a square divided by z square minus 2az cos hyperbolic theta plus a square. So a get cancels. This z is az divided by z square. This az sine hyperbolic theta divided by z square minus 2az cos hyperbolic theta plus a square. It is supposed to be, we have to write sine hyperbolic theta here. So I have written az. So here you write az sine hyperbolic theta, right? This is required answer. Now examples, right? Obtain the transform of sine 3n plus phi. Let un is equal to sine 3n plus phi. So we know that sine a plus b is equal to sine a cos b plus cos a sine b. So sine 3n plus phi is sine 3n cos phi plus cos 3n sine phi, right? So let z transform of un is equal to z transform of 3n plus phi. So z transform of sine 3n cos phi plus cos 3n sine phi. So you write this sine 3n as sine n 3 because standard form is sine n theta. So theta is 3 cos phi plus cos n 3. Right, we know that z transform of cos n theta is z minus cos theta divided by z square minus 2z cos theta plus 1. So z transform of sine n theta is z sine theta divided by z square minus 2z cos theta plus 1. So in place of theta 3. So z transform of un is equal to cos phi z transform of sine n 3 plus sine phi z transform of cos n 3. So cos phi as it is z sine 3 divided by z square minus 2z cos 3 plus 1 plus sine phi z cos 3 divided by z square minus 2z cos 3 plus 1. Now take LCM and simplify. Z into sine 3 cos 5 minus sine 5 cos 3 plus z square sine 5 divided by z square minus 2z cos 3 plus 1. Now the transform of UN is equal to, how it is like, sine A cos B minus cos A sine B, right? So this is sine A minus B. So A is 3, B is 5. So Z sine 3 minus 5 plus Z square sine 5 divided by Z square minus 2Z cos 3 plus 1. Now sine 3 minus 5 is minus 2. Sine of minus theta is minus sine theta. So we'll get here as Z sine minus 2 plus sine of minus 2 plus z square sine 5 divided by z square minus 2z cos 3 plus 1. So sine of minus theta is minus sine theta minus z sine 2 plus z square sine 5 divided by z square minus 2z cos 3 plus 1. So this writing positive term first. So z square sine 5 minus z sine 2 divided by z square minus 2z cos 3 plus 1. So this is required answer. Now move on to next example. Find z transform of n divided by 3 raised to n plus 2 raised to n into n square plus 4 cos n theta plus 4 raised to n plus 8. So I'll take un as this, So and apply linearity property. So z transform of n divided by 3n. So we can write this as to 3 raised to minus n, taking this into numerator, plus z transform of 2 raised to n into n square, taking 4 outside, z transform of cos n theta plus z transform of 4 raised to n plus z transform of 8. Take this as equation 1. So we know that z transform of n, we know that z transform of n a raised to minus n is az divided by az minus 1 raised to 2. So z transform of n 3 raised to minus n is equal to, so in place of a we have a 3, so 3z divided by 3z minus 1 raised to 2. Again we have z transform of n square a raised to n is a square z plus a z square divided by z minus a raised to 3. And here n square 2 raised to n is there, so a is 2, so 2z square plus 4z divided by z minus 2 raised to 3. Now z transform of n square 2 raised to n, so this is 2z square plus 4z divided by z minus 2 raised to 3. So z transform of cos n theta is z minus cos theta divided by z square minus 2z cos theta plus 1, and z transform of 4 raised to n, z divided by z minus a, because the transform of a raised to n is z divided by z by a, z divided by z minus a. Now z transform of 8, so we can write this 8 as 8 into 1, take 8 outside, 8 into z transform of 1, 8 into z divided by z minus 1. Now substitute this in equation 1. So z transform of n divided by 3 raised to n plus 2 raised to n into n square plus 4 cos n theta plus 4 raised to n plus 8. This is equal to 3z divided by 3z minus 1 raised to 2. Plus 2z square plus 4z divided by z minus 2 raised to 3 plus z minus cos theta divided by z square minus 2z cos theta plus 1 z plus z divided by z minus 4 plus 8 z divided by z minus 1. So this is required answer. Now move on to next one. So find the z transform of first one, 3n minus 4 sine n pi by 4 minus 5a square cos n pi by 2 plus pi by 4. So first one, z transform of 3n minus 4 sine n pi by 4 minus 5a square. So take here separately each term z transform. So 3 take it outside, z transform of n minus 4 z transform of n pi by 4 minus 5a square z transform of 1. Right. So z transform of n and z transform of 1, no problem. You need to find first this. So we know that z transform of sine n theta is equal to 2 sine theta divided by z square minus 2z cos theta plus 1. Now we want sine n pi by 4. So theta is replaced by pi by 4. Z sine pi by 4 divided by z square minus 2z cos pi by 4 plus 1. Sine pi by 4 cos pi by 4 is 1 by root 2. So z divided by root 2 whole divided by z square minus 2z by root 2 plus 1. We can write this as raised to 2, so we'll get this 1 root 2 get cancels with this, so we'll get this as z divided by root 2 z square minus root 2z plus 1. Now substituting in equation 1, so z transform of 3n minus 4 sine n pi by 4 minus 5a square is equal to 3z divided by z minus 1 raised to 2 minus 4z divided by root 2 z square minus root 2z plus 1 minus 5a square z divided by z minus 1. So next one, z transform of cos n pi by 2 plus pi by 4. So take un as cos n pi by 4 plus n pi by 2 plus pi by 4. So cos a plus b. So cos a cos b minus sin a sin b. So using that, so un is equal to cos n pi by 2 into cos pi by 4 minus sin n pi by 2 sin pi by 4. So un is equal to cos pi by 4 sin pi by 4 is 1 by root 2. So 1 by root 2 cos n pi by 2 minus sin n pi by 2. So z transform of cos n theta is equal to z minus cos theta, z square minus 2z cos theta plus 1. So we'll get here as z transform of sin n theta is z sin theta divided by z square minus 2z cos theta plus 1. So substitute theta as pi by 2. So z cos n pi by 2. So this is equal to z minus z into z minus cos pi by 2 divided by z square minus 2z cos pi by 2 plus 1. So z cos pi by 2 is 0, z minus 0 divided by z square minus 0 plus 1 because cos pi by 2 is 0. So we'll get z transform of cos n pi by 2 is z square divided by z square plus 1. So z transform of sin n pi by 2 is z sin pi by 2 divided by z square minus 2z cos pi by 2 plus 1. Sin pi by 2 is 1, cos pi by 2 is 0. So we'll get the transform of sin n pi by 2. So this is equal to z divided by z square plus 1. So z transform of un is equal to 1 by root 2 z square divided by z square plus 1 minus z divided by z square plus 1. So LCM is z square plus 1. So z square minus z. So you can take here z common if you want. So 1 upon root 2 z minus 1 divided by z square plus 1. So today I'll stop here only. Tomorrow I'll continue. Thank you everyone.